Hi and welcome to video 4, Exploring Graphs. In this video we're going to look at what it means to explore graphs, and I'm afraid it's going to be a little bit more definitionally based again. So just keep that in mind as we move forward. There's a learning goal there and a whiteboard video as always. You have now considered many contextual application of graphs, and in some of these exploring is important. Not always, but some of them. Take for example the following graph. I start at home, I'd like to finish at home, and I want to go to the library, gym, shop and post office. Now given I don't care which order I do it in, there are a few ways I can do it. I can go to the library, I can go to the shop, I can then go to the gym, I can go to the post office and I can go home. And that's all good. There's another way I could do it. I could go from the home to the library, to the shop, to the gym, to the library, to the shop, to the post office, home. That's all good as well, but obviously you can see I've wasted a fair whack of time doing a little cycle in the middle there, which I didn't really need to do. So it's not a sensible solution. In this case, I'd say that there are two sensible solutions. The first one is that green one we highlighted first. And the second one is home, library, gym, shop, post office, and then up. Those two involve going to every vertex without repeating an edge, and this will be an important aspect of what we do next. But it's an application of graph theory as well. There's two ways we could do it, or we could do it in reverse. We could go home to the post office first, and you may have other constraints. So for example, you may want to finish the visit the shop last. You may want to visit the gym first before your motivation wanes. If you go to the shop first, your milk is going to go sour in the car, for example. We'll visit that a bit more. Let's talk about some definitions. A walk is a route through a graph. So if you do any movement through a graph, it's called a walk. There's no constraints or restrictions with the walk. I've done an example there, and this is how we define walks. We just say A to B to E to F, and you've done that in green. That's what a walk is called. There's a notation. A trail is a walk with no repeated edges, but it may have repeated vertices. So I've got a trail example there in light blue. A to C to D to F to E to D. I've repeated vertice D, but that doesn't matter because that can still be a trail. But it cannot be a path. A path is a walk with no repeated edges or vertices. So whereas a trail is a walk with no repeated edges, but it can repeat vertices, a path is a walk with no repeated edges or vertices. Now we actually stopped there on the big definitions, and I want to bring forward one idea. And that's a question that somebody asked, which I thought was really good. Is there a name for a thing, I'll have a namespace, that has no repeated vertices, but does have repeated edges? And it made me think, oh, is there? I wonder what's happening here. So let's imagine we had A and B, and there's an edge between A and B, and we want to repeat that edge. If we start at A and go to B, and then we come back again along the same edge, well, you'll see that I've repeated A. And we want to know, is there something with no repeated vertices but does or could have repeated edges? The answer, obviously, when you think about it, is no, that's not possible. So therefore, why give it a name? So we've got just the three things. It's an anything walk, or it's a trail, which is a walk with no repeated edges, or it's a path, which is a walk with no repeated edges or vertices. And I've done an example of a path there. And then we can have closed or open. So a closed walk or a closed trail or a closed path means that it is that thing. So a closed walk is just an anything, but it starts and ends at the same vertex. So a closed walk will start and end at A, or start and end at E, or something like that. If it has no repeated edges, then it's now a closed trail. And if it has no repeated edges or vertices, then it's now a closed path, but we also don't often use the word path. We often call it a cycle, and I am not to be blamed for that. But ultimately, if you call it a closed path, I would know what you're talking about, but you're going to have to get used to the language cycle in case that comes up in your external exam. So there's the definitions for today, and here is some examples. On the graph below, describe a closed walk first of all. So a closed walk just means it starts and finishes at the same spot, and there's no other restrictions. So I'll keep it simple. A to D to G to A. Now I know a triangle's got only 3 edges, but you have to have 4 points to describe that triangular walk. It starts and finishes at A. An open path. So a path has no repeated vertices or edges. So in this case, I'm going to say A to B to C to D to G. So it goes A, B, C, D, G. There we go, there's an example. If I went back to A, it would be then a closed path, which is called a cycle. So let's use that. A to B to C to D to G to A. And I'll do this one in pink. I probably should have written it in pink as well. It goes the same way, but then it closes up. And of course, I could use E as well. F would be hard to use for I could use F as part of an open path, but I couldn't use F as part of a cycle because I go in and I wouldn't be able to come back out. So F could not be a closed trail, or it could not be in a cycle. So there's another thing to consider, and that's in the extension over here. Another example. In the graph below, classify each walk as either a cycle, path, trail, or closed trail. So A to B to F to D. So this is actually a nothing. I need to fix up my notes here because you can't get from F to D. So let's change that to F to E to D to B. And that'll make it work. Okay, so I was doing this in pink. It goes along to here, to there, and then back to here. It's got a repeated vertex, but it doesn't have any repeated edges, and it's not closed. Let's go back and have a look. A closed trail, or a trail, is a walk with no repeated edges, but it may have repeated vertices. So it's not a path, but it is a trail, but it's not closed. So it's just a trail. A, B, D, C. It's also not closed. A, B, D, C. But it has no repeated edges or vertices. So the best name for this one is a path. It's not closed though. And then A, C, D, B, F. In the land of excellent examples, this one is not closed either. A to C, to D, to B, to F. That's also a path, but it's not closed. So keep that in mind. So there we go. Can you define a walk, trail, path, cycle, and the idea of open and closed? And can you determine graphs of given walks and vice versa, etc., trails and paths, etc., etc.? All the best.